So we're gonna start today the new chapter, the geometry chapter. I really want you to take your time understanding, yani focusing with me and then writing the notes. So the new chapter is tangent. So it's tangent and circle. Okay, it's in the book, page 43. What we're gonna learn this? We're gonna learn what does mean tangent, how do we draw the tangent, and what is the relative position of a line and the circle. Those things don't need to write it, just focus with me, guys. Let's move. You need all the time with you a geometry set. Yeah, you need the compass, you need the pencils, you need your erasers, you need all those things with you. So don't tell me during the session, I don't have my geometry set. You need to have your compass, your set square, your ruler, your eraser, and a pencil. Okay? A pencil. Okay, let's start first. What does it mean? From here, you need to start to write. Tangent, chord, secant. What does it mean? Tangent. What does it mean? Chord. What does it mean? Secant. We have three kinds. We have tangent, we have chord, we have secant. What does it mean tangent? If a line touches the circle at one point only, that is called a tangent. So when there is one intersection with the line and the circle, we call it tangent. If a line connects the 2 points at the circle, that is called a chord. When a line is connecting 2 points on the circle, it's called a chord. And if a line intersects the circle at 2 points, that is called secant. You're going to tell me what is the difference between chord and secant. The chord is a segment, the secant is a line. The chord is a segment. You're going to see it now on the figure. Okay, so you're going to write those things, and then I will move here. This one, you need to draw it. So this is, you're going to draw a circle. Okay, this is my circle. And I have all those things on the circle. We're going to, okay, all this, you're going to draw it. I will explain it step by step. That's it. Circle, I have my center. Let me see if there is something written more. Diameter. That's it. So this is all my center. The segment that is passing through the center and cutting the two sides passing through the circle is called diameter. The radius, this is the radius. It's from the center to the circle. This is the chord. If you see a DC chord, okay, it's a segment and you are joining 2 points on the circle, but it's not passing through O. If it's passing through O, it will be a diameter. Okay, the secant, you see it, it's a line, it's a long line. It's cut the circle in 2 points. And if I make my chord longer, if it's not anymore a segment, we call it a chord. Okay, and the tangent, you see it, it cuts my circle in 1 point. So this figure is very important to draw on your copybook. Take your time drawing it. This is my circle, my center, my radius. This is the chord. This is the diameter. This is my secant, the blue one, and this is my tangent. Okay, let's move now. Tangent, this is very important. Tangent. So I have a circle, I have my center, I have my radius. To draw the tangent, it should be, guys, perpendicular to the radius. So here I should have a 90 degree. So this is a tangent. So AB is called tangent to the circle. The touching point P is called the point of contact, and it touches the circle at P, and it cuts the circle in 1 point, and it is perpendicular to the radius. And if you take the ruler and you measure from C till P, it's equal to the radius. And the distance between C and the tangent is equal to the radius. So the center and the tangent is equal to the radius. So when the distance of from the center to the line are equal to the radius, we call it tangent. Okay, so this is the tangent. So tangent, it means if you take the rule and you measure here, it's equal to the radius. So when the distance between the center and the line is equal to the radius, we call it tangent. Why I'm saying that? To prove that the line is exterior or interior, I have the same idea, but I want to compare the distance and the radius. So here there is a 90-degree angle, and if I measure CP, it is equal to the radius. Let's move now to the secant. How we prove that a line is secant to a circle. Look at it. If you measure, guys, the distance between C, if you take the ruler between C and this point here, the intersection, you will know that it's less than my radius. So secant, it cuts my circle into points, as we said before. And If I want to know how to prove, how do you prove that it's a secant? If the distance from the center to the line AB, so if I measure C till this point here, it is smaller than R, yani the distance is less than R. So when the distance between the center and the line is less than the radius, it means it's called secant. And sure, guys, now for the last one, exterior line. If I measure the distance between, so you can see it easily, it's bigger than the radius. See this distance here, it's much more bigger than the radius. So when the line is exterior, a line is exterior to my circle when, I can see it here, when the distance from C to the line is greater than the radius. So when D is bigger than R, I can say that this line is exterior. So I have tangent, and the distance is equal to the radius. Exterior, the distance is much more bigger than the radius, and interior, our secant, my distance from the center to the line is smaller than the radius. So here it's very important that you need to take your time drawing it. How are we gonna draw from an outside point of a circle to tangent to the to my circle? It's very important to know how to do it. So this is my circle and this is my point P. So what you need to do, you'll do it step by step. You'll have your protractor, your compass with you, your rule, and you do it. So I have a circle and I have, see, I have a circle and I have a point outside. I join OP first. Okay, then you take your compass, guys, and you do two arcs like this. You open the compass here, you put it here, you put your compass here on P, and you do like I'm doing here in the figure, two arcs. Okay, so I open my compass, I put it here, I do the first arc, and I'm doing the perpendicular bisector of OP. I put my compass here again and I do two arcs, one here, one here. I'm drawing the perpendicular bisector of OP. So what I'm doing, guys, I'm doing the perpendicular bisector of OP. So to draw it, you know how. You put your compass here. I do an arc, another arc. بجي على الO. I put my compass here, another arc, another arc. I'm drawing the perpendicular bisector. Or you can draw the perpendicular bisector by making OP. You take the midpoint here and then you do perpendicular. It's the same. Then I draw the circle of the center here, okay, of this center, this point here, yani where they meet the perpendicular and the OP, and of diameter OP. I draw this circle like this. So I draw it. Where the circle cuts, try to not draw it all the circle. I don't want to make too much my figure messy. Yani أنا what I need really those intersection here. So when you draw the circle, try to not make it, because I want to erase it little and just keep the intersection. Where they meet here, I can join and I have the two tangent. Okay? Where they meet, I have the two tangent. That's it. If you felt lost when you're doing this one, again, during the online session, I'm going to explain it again. So the steps are the following. I will go back. I put a point outside and I join OP. I do the perpendicular bisector. I see it. This is my perpendicular bisector. It meets my segment OP at this point here. Did you see it? I put my compass here and I draw the circle of center, this point, and radius, our diameter OP. So I draw the circle. Where the circle cut the other circle, those points, I join them with P, and those are the two tangents. Now I can see that those are my two tangents. It's very important. There is a very important property for those two tangents. Give me something very important, but we will see it later online. I will do it with you. So that's it. And I can directly say that PQ is equal to PR. This one, we're going to prove it during the online session. Why PQ? Let me move this one a little bit. PQ is equal PR because we're going to use from an outside point of a circle, we can draw two equal tangents. That's it.